For the circuit diagram, we are going to use the mesh current method to find our I of G, and our I of G is right here. So to start this, we can see that we have some current flowing through this specific part of our diagram. We know that our I of G is flowing through this part of our diagram, and then we also have current flowing through this part. So we need to solve all of these individually. Well, for our first part, we know that the current flowing through this entire part is equal to this 5 with an angle of 0 degrees. So our current here is equal to 5. Now we are going to find the current flowing through here, and we are going to call this our I2. The current will be flowing like this, and now we can use the mesh current method to find it. So we know that our I1 is 5, and it is over this J2 impedance. So we are going to have a negative because it's in the opposite direction, 5 times our J2, and this is for our first current. Now we need our second current, so we're going to have a plus I2. We're going to add all the impedances that it touches, so we will have a 5 plus J times 2 in here, and then we also have this voltage right here. Well, we know the voltage is going into the positive and out of the negative, so we will have a plus, since it's going in the same direction, 5 with an angle of negative 90. This is set equal to 0. Now we can simplify this a little bit and combine like terms. We are going to have a negative J times 10. Our I2 is going to remain the same. And then we can convert this part to the rectangular form. So we know that for our real number, we will have a 0. And then for our imaginary number, we are going to have a negative J5. So this will be negative J times 5. This is set equal to 0. However, we can combine these. So we will just have our I2, and then we will have our 5 plus J times 2, and this is equal to a J times 15. I did make a mistake. I did get the current going against our I2 this way. However, I did not get the current going for our I of G. We know we have current going this way because the current flowing through our I of G will look something like this. So since our IG is flowing in the opposite direction, we can't set it equal to 0 just yet because we still have to plug in more. We will have a minus because again our IG is flowing in the opposite direction, and it's happening over the 5 ohm resistor. So we will have our 5, because this is the resistor it's over, times our IG, and now we can set this equal to 0. And then we're going to have the same thing down here, set equal to 0. And if we move this over with this constant, we will have a plus 5 times our I of G. Remember that IG is what we want to find. Now we need to write an equation for our I2 so that we can plug it in. Well, the last thing that we can do is look at the current flowing through here. We can see that we have this first current right here going in the opposite direction over the negative 3 ohm resistor. So we will have a minus our 5, because that's the current, times our impedance, which is negative J times 3. And then we will have our minus, because we have this second current, that's over the 5 ohm resistor. So we're going to have 5 times our I2. And lastly, we're going to add our I of G. So we're going to have our IG, and then we're going to add the impedances. This impedance will cancel out with this impedance because it's the same thing but negative. And then we have the 5 ohms there. So we will have this being multiplied by 5, all set equal to 0. Now, to correctly write this out, we want to solve for our I of 2. So we are going to move our constants over. We will have a negative 5 I of 2. I'm not going to touch this yet. Set equal to our negative I of G times 5. And then we will have a minus our J times 15. Now we can divide this in by saying that our I of 2 is equal to our I of G plus our J times 3. And so this will be the equation for our I of 2 that we can plug back into here. Once we plug this back in, we're going to get this as our equation, and now we are going to multiply these two together. And in doing this, we are going to get this. So now we can subtract some things that are similar. This I of G times 5 is the same thing as this 5 times I of G, so we can cancel those out. Same thing with this J15, we're going to subtract this from both sides, so we'll cancel this out. And then after we do this, we are going to just be left with our J2IG and then our negative 6. So we can move and divide our constants over, and if we do this, we're going to get that our 6 is over our J times 2. So we can write that our I of G is equal to a negative 3. So we can write that our I of G is equal to a negative J times 3, and we don't have any V max. So our V max will be 0. That means the first part right here is 0, and the second part will be our negative 3 amps. And that's how you would go about solving this problem. If you want more network analysis problems, there's a playlist in the description, And if you want notes for this coursework, they will also be in the description below the like button.